Okay, let's just dive right into this. Welcome to today's Explainer. We're uncovering the hidden complexity and the massive global manufacturing journey behind literally one of the most ubiquitous objects on the planet, the humble wooden pencil. From kids drafting their very first stories to architects drawing up massive blueprints, pretty much everyone relies on this tool at some point. But behind this seemingly simple, everyday item, well, there's a fascinating, highly engineered journey of transformation, and we're going to trace it step by step today. To instantly wrap our heads around the sheer scale of this, just consider this staggering number: 14 billion. That is 14 billion pencils produced worldwide every single year. It takes an absolutely incredible amount of precision, specialized machinery, and honestly global collaboration to hit that kind of output. So how exactly is it done? Let's find out. Here is our factory floor map for today. We'll hit number 1, the anatomy of a pencil. 2, crafting the graphite core. 3, the wood slot sandwich. 4, shaping, painting, and finishing. 5, the mechanical alternative. And finally 6, the global pencil economy. Moving right along to section 1, the anatomy of a pencil. Right off the bat, we need to bust a major myth here. There is absolutely zero lead in your pencil. I know, pencil lead is something we say all the time, but it's totally a historical misnomer. The core is actually this carefully calibrated, completely non-toxic mixture of naturally occurring graphite and clay. See, graphite on its own, it's incredibly soft and super messy. It'll leave a mark on literally anything it touches. So to make it durable enough to actually write with, manufacturers have to mix it with clay and solidify it. And that brings us to myth number 2. That amazing aromatic cedar wood that we love because it sharpens so smoothly without splintering? Yeah, it's actually a false cedar. True botanical cedars from the Cedrus genus are native to the Mediterranean and the Himalayas, and they have needle leaves. But the wood we use for pencil casings, like the California incense cedar, actually has scale-like leaves. It's an entirely different tree. We just use it because it's soft, resists rot, and takes stains and lacquers incredibly well. Let's move to section 2, crafting the graphite core. Now, before modern mass production kicked in, this core evolved drastically. Back in 1560, an Italian couple, the Bernacottis, created early blueprints by basically hollowing out sticks of juniper wood. Jump to 1662 in Nuremberg, Germany, and they started manufacturing sticks from powdered graphite mixed with sulfur and antimony. But the real game changer? That happened in 1795. A French scientist named Nicolas Jacques Conté completely revolutionized the whole process by mixing powdered graphite with clay and firing it in a kiln at roughly 1500 degrees Fahrenheit. Oh, and fun fact, in 1858, Hyman Lipman patented the brilliantly simple idea of attaching an eraser to the end. Talk about a lifesaver, right? By tweaking Conté's ingenious mixture, manufacturers created the HB grading scale that we still rely on today. Honestly, the ratio here is everything. Adding more clay creates a harder, lighter mark. Those are your H pencils, perfect for engineers who need really precise, sharp lines. On the flip side, adding more graphite creates a softer, darker mark. Those are your B pencils, which artists absolutely love. And that standard number 2 pencil we all grew up using in school, that sits squarely in the middle at HB. Which brings us to section 3, the wood slat sandwich. All right, picture a time lapse of the factory floor right now. First, an electric saw precisely carves these thin, perfect channels into uniform wood panels. Next, those slender, kiln-fired graphite cores drop right into the grooves. Then, they apply this specialized elastic glue that's rich in polyvinyl acetate. And finally, a second grooved wood panel gets stacked perfectly on top. When you think about an educational cross-section of this process, it's just amazing. It creates a sturdy wooden sandwich flawlessly encapsulating the core inside. Moving to section 4, shaping, painting, and finishing. So we have our wooden sandwich, right? Well, now it gets pressed under a massive 1,000 kilograms of force to bond into a single solid piece. Next, industrial saws slice this block into those individual perfect hexagons, and they're shaped exactly like that for a reason, so they never roll off your desk. From there, they're sanded flawlessly smooth, coated in that classic protective yellow lacquer, and lastly, a lightweight aluminum ferrule is crimped onto the end to securely hold that iconic pink eraser. Let's look at section 5, the mechanical alternative. Okay, but what if we want a constant line thickness, and we want absolutely zero wood shavings? Well, that's when we turn to the precise technical aesthetic of a mechanical pencil. This instrument is designed to keep ultra-thin graphite constantly advancing through a lead shaft. The lead is housed securely inside a barrel, it's capped with an eraser shaft, and it exits through a very precise cone cap at the bottom. The best part? No sharpener required. Now, these modern, reusable instruments generally use one of three different mechanisms. First, there's the historical screw-based system that twists a slider down the barrel to push the lead forward. Then you have the ratchet-based system. This is definitely the most common one we see today. Basically, clicking a button separates small jaw pieces to let the lead inch forward bit by bit. And finally, there's the clutch system. This uses a drop-through mechanism to hold much thicker leads, usually between 2 and 5.6 millimeters, which is super popular for heavy drafting work. And finally, Section 6, the global pencil economy. Zooming out a bit, with massive operations primarily based in China, the US, and Brazil, the scale of natural resources required for this industry is just vast. To put it into perspective, a single large factory can consume 34,000 kilograms of wood just to manufacture 1 million pencils. And since an average tree yields about 170,000 pencils, that means the global industry fells roughly 100,000 trees every single year just to meet that 14 billion pencil demand we talked about earlier. So here is the crucial point we're left to ponder. As we appreciate the sheer engineering behind those 14 billion pencils, from that 1500-degree kiln-fired graphite to the perfectly sliced false cedar wood, what exactly does the future look like? I mean, with 100,000 trees felled annually, will innovations like upcycling municipal paper waste into remanufactured pencils rewrite the future of how we make this essential tool? It's a fascinating question about a tool that has literally empowered human creativity for centuries. Thanks so much for joining me on today's Explainer, and hey, keep questioning the everyday objects around you.